Hey guys, Dr. Cadell here, and this is the Empirical Formulas Lab. So first thing, let's talk about what empirical formula means. It means the formula that you observe experimentally. And this is related to how scientists originally figured out the formulas for chemical compounds. They did experiments just like we're going to do today. In terms of chemistry, the empirical formula means the smallest whole number ratio of the elements in a formula. That's what we're going to figure out today. Now, the thing is, we're going to synthesize two different compounds, zinc iodide and magnesium oxide. And we know from several places in the course that the actual formula for zinc iodide is ZnI2, 2 iodine atoms for every 1 zinc atom. And for magnesium oxide, it's 1:1, 1 magnesium for 1 oxygen. But what we're going to do with our data is we're going to calculate that and see how close we come. So in the first part of the experiment, we're going to synthesize zinc iodide. And the synthesis is a combination reaction, zinc combining with iodine to make one thing, zinc iodide. It's also, by the way, a redox reaction. For the magnesium oxide portion, we're going to combine magnesium with oxygen to make magnesium oxide. Combination reaction, also a redox reaction. The way we're going to do this reaction up here is we're going to weigh out some zinc, about 1.2 grams, and some iodine, about 1.2 grams. Put them in the same beaker, add some acetic acid. The acetic acid, guys, it's just basically a medium that allows the atoms to react with each other. It also does a few other things for us. It keeps any zinc hydroxide from forming, which would interfere with our reaction. What this is going to look like, you'll see this, but let me show you or explain what this is going to look like. When you first mix these two together and put the acetic acid in, you'll have a clear liquid on top of the zinc and the iodine. But pretty soon the iodine is going to start dissolving, and when it does, it makes that solution a dark red color. And that's really nice for us because the way we have this set up, we have zinc in excess by far. There's way more zinc than we need to use up all the iodine in that mixture. So when this reaction is done, all the iodine will be gone, but there will be some zinc left. That's nice for a couple of reasons. One is that gives us a real good visual indicator of when this reaction is complete, because iodine gives that solution this dark red color. When that dark red color is all gone, when it's clear again, we know the reaction is complete. Actually, what's going to happen is it's going to be clear, and then when this starts dissolving, it'll turn red and dark red. And then as it reacts, as the iodine gets used up and there's less and less iodine in the solution, it's going to look this yellow, like this yellow color. When all that's completely gone, we know we're finished. The other thing that's nice about this setup with the excess zinc is that at the end, because there's going to be some excess zinc left over, it ends up that all we have to do is weigh how much zinc is left over. Because knowing how much zinc we started with, how many grams, knowing how much is left over, that'll be in the beaker down here, the difference in those two masses is going to be how much zinc reacted. And that's what we need to get our formulas, because what we're going to do is we're going to calculate our empirical formula for zinc iodide. To calculate that, we need to know how much zinc reacted and how much iodine reacted. So like we just said, the amount of zinc reacted is the difference in the mass of how much we start with and how much is left over. The amount of iodine that reacts, well, it all reacted, so however much we weigh out, that's how much reacted. Now, in terms of the calculations, and I take you through this in the lab report, but we need to know the ratio of the moles of zinc to moles of iodine, or vice versa. But knowing the grams, we can get to moles, because remember, the conversion factor that goes from grams to moles is molar mass. So that's real easy. Knowing the grams of zinc that reacted, grams of iodine that reacted, we can get the moles of zinc, moles of iodine, and the empirical formula. Now for the second part of the experiment, the synthesis of magnesium oxide, what we're going to do is we're going to weigh out some magnesium ribbon, and we're going to heat it up in a crucible. Where the oxygen comes from is from the air, because we're breathing oxygen right now. There's one little twist to this though, because the air that we're breathing is mostly, it's like 77, 78% nitrogen, And nitrogen, when you heat up magnesium, will also react with that. So we get this side reaction going on. But it ends up we can take care of this. What we're going to do is we're going to add some water after we've heated this up for a while when it's cool, and then heat it up again. And that ends up taking care of the nitrogen, and we end up with all magnesium oxide. And so we're going to weigh out the magnesium. We'll know how much, and we're going to weigh at the end, we're going to weigh the magnesium oxide. So the difference between how much the magnesium oxide weighs at the end and how much magnesium we started with is how much oxygen reacted, because all the magnesium will definitely react. So at that point, we'll know how many grams of magnesium reacted, how many grams of oxygen reacted, use the molar mass to convert to moles, and get the ratio. And that's really all there is to it. So why don't we go on over there and get started on the experiment. All right, guys, so the first part of the empirical formulas experiment, the synthesis of zinc iodide, it ends up this time we actually do need to know how much the empty beaker weighs. So that's the first thing we're going to do is we're going to weigh the empty beaker. So make sure the balance says 0 with nothing on it. Place the beaker in there. Record that number. That's your A1, 3 places past the decimal, little g for grams. Then, okay, now with the beaker on there, once we got the mass, we're going to tear out the balance. So now it says 0 with the beaker on there, and we're going to add our zinc first. So we want about 1.2 grams of zinc. And it's probably less than you think. This is kind of dense. A little more. A little bit over 1.2 grams, but it doesn't really matter because this is going to be in excess. So write that number down. Original mass of zinc, this is A2. Then with the beaker and the zinc on there, the next thing we're going to do is weigh out some iodine in there. So we need to tear out the balance once we get this mass. So now the balance says 0 with the beaker and the zinc in it on there. So take it off. We want to be careful not to add too much iodine because it will start reacting with the zinc once we put it in there. And these are little tiny spheres. It's probably less than you think. So add a little bit and then kind of go back and forth till you get about 1.2 grams. Usually what I do is when I first put the first little bit in and I see how much it weighs, it gives me, okay, so it's a little bit less than half, so a little more than double. So like 1.1 grams there, maybe just a little bit more. There we go. So it doesn't have to be exactly 1.2 grams. Write that number down in our data tables. That's the mass of iodine, A3. Real quick, it's really important that you put the, well, lids always go back on everything, but particularly the iodine. So what happens is this iodine will start subliming. It actually goes from the solid to the gas phase, and it gets all in the atmosphere. All right, so we have this. Now, start the reaction going at a good speed. We're going to add about 5 milliliters of acetic acid, 0.2 molar acetic acid. This doesn't have to be measured out carefully, so I'm just going to use the transfer pipette. It has marks on it. Pull about 3 mils and then 2 mils. Or really just 2 pipettefuls would be plenty. That volume is not real important. Maybe just a little bit more. All right, so now look at this real quick, and then we're going to get started on the second part of the experiment, the magnesium oxide synthesis, while this is reacting. But if you look at that, so it's going to get darker and darker and darker as the iodine dissolves, and then as it starts reacting with the zinc, then it's going to start getting lighter and lighter and lighter. And we want to make sure it keeps reacting, allow it to react all the way until that solution on top is perfectly clear again. And to make sure that, as it gets towards the end, we're going to put it on top of a piece of white paper and make sure there's no yellow left in that solution at all. But now that it's started, we can go start the second portion of the experiment. All right, guys, so now while we're waiting for the zinc and the iodine to react, we're going to start the synthesis of the magnesium oxide. First thing we need to know is the mass of the empty crucible with its cover. So we make sure the balance says 0 and place them together, the crucible and the cover on the balance. Close the door, record that number 3 places past the decimal, little g for grams. That's your B1. Then we need to weigh out about 0.3 grams of magnesium ribbon here into that crucible. So what we do is we take off the lid, tear the balance with the crucible on there. So now it says 0 with the empty crucible. Take it out. And magnesium ribbon cuts really easily with a pair of scissors, so I'm going to estimate maybe about that much is 0.3. We'll see. I'm going to curl it up so that it'll fit inside of the crucible. And that's about half of what we need, so I'm going to add about that much again. That's a little under 0.3, good enough for us. This number, 3 places past the decimal, little g for grams, that's our B2. So now we're ready to start the reaction, which means we're just going to basically heat this up with a Bunsen burner. So if we look at this setup over here, see how dark that iodine's getting, or the solution above it? So what we have here, guys, is we have an iron ring, a clay triangle, Bunsen burner, lighter, and our crucible with the magnesium in it. First thing we're going to do is light the Bunsen burner before we put it under here, because we need to adjust the height of this. What we need to have is when it's set up like this, we need the hottest part of that flame, which is the tip of the inner bright blue cone of the flame, just touching the bottom here. Once it's been there for just a few seconds, this gets really hot, so we don't want to put it under here yet. We're going to light the flame and adjust the height here, then put it underneath. So to light the flame, first thing we're going to do is make sure that this needle valve is set properly to start. So close it all the way, back it out about 1 turn, about 360 degrees. Adjust the gap here to where it's about 1 millimeter between the top of this outside gap and the top of the threads. Now we're ready to light it, and we'll adjust the flame once it's lit. So turn on the gas. Remember, when this handle is parallel to the nozzle, it's on. Like that. So now looking at that flame, I can see it definitely needs more oxygen, maybe a little bit less fuel. So the first thing I'm going to do is decrease the amount of fuel, which means I'm going to turn this needle valve, yes, and I'm going to give it some more oxygen by opening the gap here. So if you can see that bright blue cone in the middle, right about there is the hottest part of that flame. That's what we want touching the bottom of this crucible. So if I hold it up next to it, you can see that I guess pretty good. It might be a little bit low, so I'm going to move this up a little bit. Tighten this guy down. And we also want to make sure, by the way, that the cover of the crucible has a little opening there. We need some way for the oxygen to get in and react. So that looks like that height's pretty good. I'm going to stick it under here, and we're going to let it heat up for 20 minutes. It's going to glow red, orange. And so now that we've got this going, we can come back over here and check on the zinc iodide. All right, guys, so checking back in on the zinc iodide, looks like it's pretty much all reacted. If we hold a piece of white paper up in back of it and look through that solution, we can't see any yellow, no red. So that means that all of the iodine has reacted with the zinc, and if you can see, there's still some excess zinc in the bottom, And we're going to end up weighing that eventually. All right, guys, so now that all the iodine is reacted, we can go on to the next stage where we decant and wash this. But first, it's been 20 minutes over here. The magnesium looks like it's all reacted, so we're going to go to the next step here first and then come back over here. So we turn off the gas. Bunsen burner, pull this out. Now this is really hot, so we have to be careful. So what we're going to do is we're going to take our wire gauze and put the top on, turn it over like this, the crucible tongues, lift it up, set it on the wire gauze. If we look inside of here, we can see what it looks like now. We're still not quite finished. This is what the magnesium looks like here. That's magnesium that has reacted with mostly nitrogen in the air and some of the oxygen. So there's magnesium nitride in here, as well as magnesium oxide. Our goal is to get it all converted to magnesium oxide. That's why once it's cool, we're going to add some water and heat it up again. And what that will do, that will convert any magnesium nitride in there into magnesium oxide. But we have to make sure that's cool first, because if we just put cold water in there, it's going to crack that crucible. So while we're waiting for that guy to cool down, we can come back over here and finish up our zinc iodide. So now we're going to decant this solution off into our waste beaker. And that just means pour off most of the liquid. The goal here is not to get all of the liquid off. That doesn't really matter, but to make sure that we do not allow any of the zinc to get poured over.
Would you be able to do it in a way that
Yeah, but now I have to do it right. Can you see? So there, I saw a little piece of the zinc coming over, so I stopped. It doesn't matter that there's still that much solution in there. So now what we're going to do is we're going to wash it 3 times with acetic acid. So each time, I say about 3 mils, about 1 transfer pipette full. Just squirt it in there. Swirl it around a little bit, let it settle, decant that solution off. Again, it doesn't matter that we don't get all the liquid. I'm going to do that 2 more times. Now that we've washed it 3 times with the acetic acid, we're going to wash it 3 times with deionized water. Now this we don't have to really measure out carefully, about the same volume. So about that much right there. And again, we're doing our best not to let any of that zinc get carried over. Total of 3 times washing with the water. And now, okay, it's still wet. There's still some water in there. We don't care. What we're going to do is we're going to set this in the oven and let it dry in the oven until next week. Come back and weigh it. Once we weigh it, that will be the mass of the beaker after dry, our A4. And that's the first part of the experiment. Now that the crucible is cool enough, just so long as it's cool enough to pick up without hurting yourself, we're going to add about 3 mils of DI. We don't have to measure this out. So I'm just going to add about that much water. Now we're going to start heating it up again, but if we just go full force, this will spatter out and we'll lose material and our masses are going to be wrong. So what we do is we're going to adjust the flame for the first 5 minutes so that it's gentle heating. We put this back on the same way. The crucible lid has a little opening on the crucible, on the clay triangle. So light our Bunsen burner. To adjust the flame towards gentle heating, I'm going to just decrease the amount of fuel that the flame has. And the amount of oxygen too. So we're detuning our flame kind of. So we're going to put it under here and go for 5 minutes. And then once the 5 minutes is up, we're going to make this back into a really hot flame and heat it for 10 more minutes. After that 10 minutes is done, we're going to take it off, let it cool, and then we weigh the crucible with the magnesium oxide in it. Cool enough. All we have to do is take the crucible, the cover, and the magnesium oxide, which is inside, go over here and weigh it. So we want to make sure the balance says 0. Place it on the balance. Record that. That's our B3, the mass after heating. And we're finished with the experiment. And that's all there is to it.